Have you ever pondered the origins of our home, Earth? In the depths of space, a cloud of gas and dust, known as a solar nebula, began its journey. Its own gravity caused it to collapse, setting in motion a cosmic ballet. As it contracted, it started to spin, gradually flattening into a rotating disk. In the heart of this swirling maelstrom, a young star was born. This star, a fiery beacon amidst the darkness of space, is what we now know as the Sun. But the Sun was not alone. Around it, smaller particles embarked on a dance of their own. Colliding and sticking together, they formed larger and larger entities. These were the building blocks of our planets, the planetesimals. A cosmic symphony was in the making, a grand spectacle of creation and destruction, of matter coming together and breaking apart. And thus, around this young sun, the stage was set for the birth of Earth. In the vast cosmic theater, the next act was the creation of planetesimals. As the solar nebula continued to contract and spin, a unique process unfolded around the young sun. The smaller particles within the rotating disk, like cosmic dancers, began to collide and stick together. This was not a random process, it was a cosmic ballet choreographed by the laws of physics and gravity. These collisions weren't catastrophic, but rather, a slow and steady process of building. Think of it as the universe's own version of a snowball fight. Each impact caused the particles to grow, forming larger and larger objects, which we call planetesimals. Over millions of years, these planetesimals continued to collide and merge, growing in size and mass. It was a relentless, chaotic, but necessary process shaping the building blocks of our solar system. These planetesimals eventually evolved into protoplanets, the precursors to the planets we know today. The Earth, as we know it, began its journey as one of these many protoplanets. From a protoplanet to the Earth, the journey was marked by a significant process: differentiation. As Earth grew and heated up, heavier materials like iron and nickel sank towards the center, forming a dense core. The lighter materials, meanwhile, rose towards the surface, creating a rocky mantle and a thin crust. This process, known as differentiation, gave Earth its distinct layered structure. As millions of years passed, the surface of Earth cooled down, forming a solid crust. But the story doesn't end there. The Earth's atmosphere started to develop not just from gases released from its interior, but also from the impacts of comets and asteroids. These celestial bodies brought with them water and volatile compounds, contributing to the development of our atmosphere and oceans. This transformation from a hot, molten protoplanet to a differentiated planet with a cool surface and a developing atmosphere set the stage for the Earth to become a hospitable place for life. The early Earth was a hotbed of volcanic activity and frequent impacts, a far cry from the planet we inhabit today. Picture a world ablaze, its surface seething with molten rock and streaked with meteor impacts. This was Earth in its infancy, a newborn planet in the throes of formation. Yet, even in this turbulent time, the stage was being set for something extraordinary. As the eons rolled by, the planet began to cool. The molten surface solidified, creating the first landmasses. Oceans began to form as water vapor in the atmosphere condensed and fell as rain, filling the basins between these landmasses. These oceans became the cradle of life, hosting the first simple organisms. And so, life emerged, defying the odds in a universe that can often seem hostile to it. Over billions of years, the Earth transformed from a fiery, volatile planet into a nurturing cradle for life. The formation of Earth is a tale of cosmic proportions, quite literally. It's a story that starts with a humble solar nebula, collapsing under its own gravity, spinning and flattening into a disk. At the heart of this disk, our sun, a fledgling star, ignited. Around it, cosmic dust and debris collided and coalesced into planetesimals, the building blocks of planets. These planetesimals grew and merged, forming protoplanets, one of which was our Earth. A process called differentiation layered the Earth into a dense iron core, a rocky mantle, and a thin crust. As the surface cooled, an atmosphere developed, birthed from the gases released from the Earth's interior and from comet and asteroid impacts. This primordial planet was a hotbed of volcanic activity, constantly reshaped by powerful forces. But over billions of years, the Earth cooled, oceans formed, life emerged. The formation of Earth is not just a story of geological processes, but a testament to the marvels of the universe and its unending potential for creation.